Welcome to QuickSpots. In this video, we'll run through all of the controls in the QuickSpots tool, as well as a few features of the main application that you'll need to be aware of. Let's start with the main application. The first thing you'll need to know is how to open an image. When you have an empty viewport, this can be done by double-clicking on the viewport. If there's already an image open in the viewport, you can replace it with a different image by clicking the Open icon on the toolbar. When an image has been opened, depending on its size, it may not be entirely visible on the screen. You can resize the image to fit entirely within its viewport by selecting Size Image to Viewport from this icon on the toolbar. You'll notice that when you do this, the image may be stretched one way or the other to fit the viewport. This does not affect how the image is processed, only how it's displayed. If I resize the viewport like this, you can see that the image appears more normal. Now let's open the QuickSpots tool by clicking its icon in the toolbox. The QuickSpots tool has three tabs. The first is the Setup Template tab. From this drop-down list, you can select the model of the spot array you are going to analyze. For example, the image I have open is model ARY007 from R&D Systems. To analyze an array from your image, the first thing you'll do is draw a rectangle around it. I'm going to purposely draw the rectangle badly so that I can show you how to resize it just in case you ever need to do that. By default, the application is in draw mode, so if I try to move my rectangle, I end up just drawing another one instead. From this button on the toolbar, I can change the ROI, or region of interest, mode from draw to move, which will enable me to move or resize my rectangle. While the QuickSpots tool is open on the Setup tab, the ROI mode can only be changed to draw or move. If you need to change to a different mode, either close the QuickSpots tool or switch to the Results tab. In Move mode, I can select an ROI by right-clicking inside it, and then I can use the left mouse button to resize it using the little squares on its edges, or move it by clicking and dragging anywhere inside it. When an image has multiple ROI rectangles drawn on it, QuickSpots will use the active ROI, which is displayed in red and has resize handles on it, and ignore any inactive ROIs displayed in green without resize handles. Generally, the next thing you'll do when using QuickSpots is click the Continue button, but before we do that, let me show you what these four buttons do. The top two buttons rotate the image counterclockwise and clockwise. The bottom two flip the image horizontally and vertically. Before you click Continue, you'll need to have your image oriented as shown in its kit documentation. If it's crooked, that's not a problem. Just use the buttons to get it to the orientation that's closest to the kit documentation. When you rotate or flip an image, any ROIs that you've drawn on it will disappear. So I'll redraw our rectangle around this top array and click Continue. Clicking Continue on the Setup tab initializes a new dataset and takes us to the Autoplace tab, where we can align the kit template over the image. You'll notice that our image now contains only the area that was inside our rectangle, that the brightness values of the image have been inverted so that we have light spots on a dark background, and that QuickSpots has automatically aligned the template circles to our image. Depending on the quality of your image and the brightness of the spots, QuickSpots may need you to make a few adjustments to the alignment of the template circles. Often the only thing you'll need to do if the template is misaligned will be to adjust the threshold slider. QuickSpots uses this slider to recognize which parts of your image are array spots. If you move it too far to the left, the spots will run together, and eventually the entire image will become one big blob. With a high-quality image like this one, you'll want to move it to the left until as many spots as possible are highlighted but none have merged together. When you release the mouse button, all of the spots that have been recognized will be outlined in purple. These are called blobs, and QuickSpots will use them to align the template circles. Sometimes, if your spots are faint, or if the image is over or underexposed, QuickSpots may not be able to figure out the correct alignment simply by adjusting the threshold. In that case, usually the next thing to do will be to set anchors. Set Anchors mode enables you to manually position up to 3 circles in their correct locations. QuickSpots then uses those anchors to help it figure out the correct alignment of the rest of the circles. As you can see, if I move this circle to the wrong location, many of the other circles get pulled out of alignment. To set an anchor, right-click a circle to select it, and then use the left mouse button or the arrow keys on your keyboard to position it where it belongs on your image. Setting anchors works best if you anchor circles that are near the corners of the array and aren't too close to each other. Another thing you may need to do to correctly align your template is to delete noise. Sometimes QuickSpots will find blobs, those purple outlined areas, where there's handwriting or some other marking on your image, or multiple spots may get merged into one blob based on your threshold setting. In fact, there are times where you'll purposely allow multiple bright spots to merge into one blob in order to make blobs from more of the faint spots on your array. If any of those blobs that don't represent a single array spot are causing problems with the template alignment, you can delete the blobs by right-clicking to select them and then left-clicking the selected blob to delete it. Deleting a blob does not affect how the data is processed by QuickSpots because only the circles are considered when generating the data. The blobs are used only to assist in aligning the circles. Finally, after you've used threshold, anchors, and deleting noise to get your template aligned as closely as possible, if there are still circles that aren't quite correctly aligned, you can fix them in fine-tune mode. To fine-tune the position of a circle, right-click to select it, and then use the left mouse button to click and drag it, or use the arrow keys on your keyboard to position it as desired. You'll always want to fine-tune last after all the other steps, because any adjustments made in fine-tune mode will be lost if you make any of the other types of adjustments. For example, if I move my anchor circle, you can see that the circle whose position I fine-tuned moves as the overall template is realigned. These 4 buttons are the same as what we saw on the Setup Template tab. If you forgot to orient the image correctly before coming to this tab, you can do that here. This field contains the name of the dataset for this array. QuickSpots automatically generates a dataset name by adding a number to the file name of the image. If we were to go back to our image and process another of the arrays, the default dataset name of the next one would end in 2, and so on. In this case, you may recall that the number 812 appeared on the image next to the array that we are processing, so we might want to change the 1 to 812. Finally, we have 2 buttons here at the bottom. The Reset button resets the circle alignment to the state it was in when we first arrived on this tab. Most likely, the only time you'll use it is if you want to unanchor a circle that you've set as an anchor to enable you to set different anchor circles. The Invert button inverts the brightness values of the image. The only time you'll need to do this is in the rare event that QuickSpots incorrectly arrives on the Autoplace tab displaying dark spots on a light background. This should only happen in the case of extremely grainy images or other severe image quality issues. With the circles aligned to your satisfaction, the next step is to click Generate Results. As you can see, we have one dataset here for the array we just processed, but I want to show you what this looks like after multiple datasets have been generated. So I'm going to quickly go back to the Setup Template tab and process the next array. I'll size the image to the viewport to make the next array visible. Draw a rectangle around it. Click Continue. And the alignment looks good, so I'll click Generate Results. And now we have 2 datasets. Since I didn't modify the name of the second dataset, and since we did change the 1 in the name of our first dataset to 812, our second dataset gets named with the number 1 at the end. If we hadn't renamed the first dataset, its name would end in 1 and our second dataset's name would end in 2. This control above our dataset list enables us to select an array model. When we first opened the QuickSpots tool, ARY022B was selected on the Setup Template tab, so the model gets listed here, but if we select it, no datasets are displayed since we didn't generate any of that model. So let's switch back to ARY007. With multiple datasets in the list, if I click to select one and click one of these export buttons, only the data from the selected dataset will be exported. But what we want to do is export both of the datasets in a single file, so I'll click this button to deselect any selected dataset. With no dataset selected, if I click an export button, all the datasets shown in the list will be exported together. If you have several datasets and you want to export more than one but not all of them in a single file, you can select those you don't want to export and remove them from the list by clicking this button. This does not actually delete the data, it just removes the dataset from the list so that it won't be exported. We can restore any hidden datasets to the list by clicking this button. Note that when you close the QuickSpots tool, all of the datasets are lost, so you'll want to be sure to export your data before closing the tool or exiting the application. So now let's export our data and see what it looks like. QuickSpots exports data to a CSV or comma-separated values file in one of three formats. The single column format has one column for each data set. Let's give it a look. I'm just going to overwrite this file each time I export since I don't actually need to keep the data. So now I'll open my spreadsheet program. I use LibreOffice Calc, but you could do the same thing in Microsoft Excel, Google Sheets, or any other spreadsheet program. And we'll open the file. And as you can see, we have the name of each data set with the values of the spots in the single column below. Each number is the average brightness of the pixels inside the corresponding circle. The numbers can range in value from 0 to 65,535, which is the range of a 2-byte integer in a computer. There's no particular significance to this numeric range, it's just the range that QuickSpots happens to use. What matters is the values of the spots compared to each other. If we scroll down, we'll find the values of the spot pairs. Each number here is the average of the two spots in the pair minus the average of the negative control spots. In other words, we're subtracting the brightness of the background from the value of the spots to get a corrected value that, as noted in the R&D Systems documentation, can be compared to other arrays. So let's go back and take a look at the multi-column format. We'll export the file and open it in our spreadsheet program. As you can see, we have the same two data sets, but now each has two columns underneath it containing the raw spot values and the corrected pair values displayed once for each spot pair. So it's the same data as the single column format, but just organized differently. And finally, let's look at the grid format. We'll export the data and open it in our spreadsheet program. And you can see that this format is very different from the other two. First, the numbers you see here are the raw values of the individual spots. In this format, we don't calculate the corrected values, though you could do that easily enough by averaging the values for any spot pair and subtracting the value of the negative controls. And second, the numbers for each data set are laid out in a grid that matches the arrangement of the spots on the arrays. If we look at the array image, we see that there are gaps in the data in all the same places where the array doesn't have spots. And with that, we're done covering everything you need to know to use QuickSpots to quickly and easily generate spreadsheet data for your spot array images. Thanks for watching.